Module 1, Section 8, Objective 6. And this is applications and not dividing whole numbers. Sorry about that. The objective is to solve application problems using multiplication of whole numbers. So we're going to go through the entire POLIA problem-solving strategy as we do these. And we're looking for key words that mean multiply. So some of these that we've talked about in a previous video. Okay? So starting with example 4, problem 1. If an average person can type 55 words per minute, how many words can be typed in 10 minutes? In 1 hour, so that's 60 minutes. Now we have 2 answers here. Okay? So just a reminder about what POLIA is. The first step is to understand the problem. And to do that, you read through the entire thing. Sorry, I'm writing over the other problem. And see if there's any vocabulary you need. See if, you know, what it's actually asking for. Like finding that there were 2 answers. That was important with the understanding the problem. Another part of understanding it is kind of doing an estimate if it's possible. And then we're going to build a plan. Followed by execute the plan. And finally, review everything. And the reason I have chosen those specific words is because Uber is a good way of remembering it. Okay? So if I refer to Uber, that's what it is. Okay, so we read through our problem. Now, understanding it, can we take a guess at what it's going to be? Let's find out. Okay, so 55 words a minute. And we want to figure out 10 minutes and then 1 hour. So 55 words every minute for 10 minutes, that's kind of hard to estimate without actually doing the problem. So I'm going to leave out the estimate section of understand because these are so short. Okay? When we get a more complicated problem, that will be more important. Okay, so how are we going to do this? We are going to figure out 55 words a minute for 10 minutes. So technically, we're adding 55 10 times, right? So we could do that. That's repeated addition. But because we know that repeated addition is multiply, we're just going to go 55 times 10. Okay? And using the shortcut that we know, we can do 55 times 1 and then tack 1 0 on the end. So 55 0. 550 words in 10 minutes. Okay, now we have to figure out how many words in 60 minutes or in 1 hour. So you've got 2 options this time. You can start over and times it by 60 this time instead of 10, or you could take this answer and times it by 6, because 60 minutes is 6 times 10 minutes, right? I'm just going to start over like I have written down here. Okay, so 55 times 60. So 0 times anything is 0, so I have a whole row of zeros there. And now the bottom, I'm going to shift over 1. 6 times 5 is 30. Carry 3. 6 times 5 again is 30. Add 3 is 33. So 3,300 words in 1 hour. Question C. A large classroom auditorium is made up of 20 rows of chairs. Each row has 26 chairs. How many seats are available in the large classroom? Okay, we could do an estimate. And again, this one's so short that it might kind of be useless, but let's take a look at it. Okay, so 20 is a nice round number, so we don't need to worry about that. 26, I would possibly make it 25 or round it up to 30. And then and times those by 20. That would give you an average, or an estimate, sorry, of 500 or 600. So, and those are pretty far away, but at least it gives you a starting point for an estimate. Okay, do we know what we're doing on our understanding? I kind of went ahead and did the problem before I explained what it is, but here we go. We have 20 rows, and I'm not going to draw all 20 rows, but here we go, 20 rows. And each row has 26 chairs, so 1, 2, 3, 4, 5, etc. Okay, so we have 20 rows of 26 chairs each. So, can you see how this is repeated addition again? We have 26 on each row, and we have 20 rows. So we're going to go 26 times 20. And that explains up here why I did those, and I apologize for doing that first. Okay, so 26 times 20, we're going to do our shortcut. 26 times 2, and then put the 0 on the end. Okay, so 26 times 2, 12, carry 1. 2 times 2 is 4, add 1 is 5, so it's 52, and that 1, 0. And so that means there's 520 seats available. And that's between the two, so that's a pretty good estimate. Okay, now on neither one of these, I didn't do a review. Okay, so let's take a look at C and do the review portion of our pollia. Okay, so because it's in between the two estimates that I got, for 25 I rounded down and 30 I rounded up, so it should be in between the two. And we got that. So it looks pretty good. Okay, does it make sense that 520 seats in a large classroom auditorium? Yeah, it makes pretty good sense. Was there an easier way of doing the problem? If I would have added all the 26s up, I would have said, yeah, there's going to be an easier way, and that would be to multiply. But I think by multiplying, we did the easiest way. Okay, and you could go through that same process over here with the words per minute. Just be certain that you have a review portion, because you will be tested on that part, right? Question B. Becky bought each family member in the math department a package of 12 pens. If there are 34 faculty members in the math department, how many pens did Becky buy? It's a pretty exciting present, isn't it? Actually, math teachers would probably appreciate them. Okay, let's take a look at it. Understand. So, Becky's buying everybody the same thing. So, 12 pens to 34 people. So, each person gets 12, and there are 34 people, so that's going to be quite a bit. Okay, let's do a little bit of an estimate here and see what we can come up with. So, the 12 pens, if we round that to 10, and the 34 faculty people, you round that to 30. Times those, we get 300. Okay, maybe if I did the 30 here, but I left this as 12, because I can do 3 times 12 if I know my 12 times tables. I get 360. Is that closer? Maybe. Okay, I'm going to slide it just a little bit. Okay, what if I did 10 here, but I'm going to round the 34 to 35. So I get 350. Okay, so any of those would be valid estimates. Okay, so let's see, what's my plan? If I know that each faculty member gets 12 pens, I can add 12 for each person until I get to 34. But that's ridiculous, isn't it? So let's go ahead and do multiply instead, because repeated addition is multiply. Okay? Execute. Here we go. 2 times 4 is 8. And 2 times 3, we're going this way, is 6. Now, for multiplying by the 1, we have to move over. So 1 times 4 is 4, and 1 times 3 is 3. Now we're adding. So 8, 6 and 4 is 10, carry the 1, so 408. So there's our estimates, and we got 408. Is that close enough? And yeah, I would say it is, because we rounded down most of the time, right? So 10 was 12 rounded down, 30 was 34 rounded down, so this is going to be a lot lower than what we started, or what we actually got. Okay, 12 stayed the same, but then the 30 rounded down, so it's going to be lower, which it is. 10 rounded down, 35 rounded up, so that's closer, right? All right, let's get our review. Let's make certain we have our label. So what are we looking at? How many pens? So it's 408 pens. And is there a shorter way of doing that? Probably not. I'd say that's pretty short. Okay, problem D. Here we go. For Christmas, you want to buy 6 nicely framed copies of a family photo. Each copy cost you $175. How much did you pay for all the family photos? Okay, now this one's a little bit more difficult because you don't see numbers. So I like to rewrite them, okay? So 6 is our first number, and $175 is another number. Okay, so that's part of my understanding of this problem, is figuring out what the numbers actually are. Okay, so now what is it asking me? If each copy costed that much, and I want to buy 6 of them, it's going to be a lot of money, isn't it? We're going to have 175, for each family member. Okay, whoa, yeah, I don't know my numbers very well today, apparently. Okay, so I could do this, right, for all 6 of them, and then add them up. But that's kind of ridiculous, and it would be very long and hard, so let's do, this is coming up with my plan now, right? Multiply. So 175, let's times it by 6. Okay, now let's do an estimate while we're at it here. 6, we could round it up to 10, and we could round 175 up to 200. Timesing those gives you a 2 with 3 zeros, so 2,000. Okay, so that's one option. Okay, another option would be to round it differently. Let's take a look at what else we could do. Let's say 6, let's round it to 5. And then the 175, we could go up to 200 again. So 1,000. And those two numbers are way different. By $1,000, they're different. Okay? So you can see that sometimes estimating is helpful, sometimes it isn't. But let's go ahead and multiply this out and see what we get. So we're on the execute stage. So 6 times 5 is 30. 6 times 7 is 42. Add the 3 is 45. So carry the 5, or put the 5 down, carry the 4. 6 times 1 is 6. Add 4 is 10. So 1,050. That's closer to the 1,000 than it was to the 2,000. Okay, so 1,050. And does that make sense? I would say it does. Because let's see, if I rounded this one to 200 and we had 200 6 times. So this is another estimate. So it would have 1,200 would be my estimate. And that's close too, right? So no matter how we look at it, we get it close to one of our estimates. And that is a lot of money for Christmas presents.